Good morning, mathematicians. Check it out. Look who doesn't have OBS appearing at the start of their videos now. That's because I'm in the big leagues, baby. All thanks to Nikolai. Is it Nikolai? I don't know. You should go check out his channel, though. It's great. Yeah. You should go check out this guy's channel. He commented on yesterday's video. Good stuff. What are we doing today? Spectral sequences, of course. Go check out this guy's channel. What about spectral sequences? Well, let's return to the paper that is motivating me. After I get set up here. And there's another kind of spectral sequence I think we want to look at. We looked at the growth and Deke spectral sequence yesterday. There's another one that was mentioned in this paper. Yes, exactly, Boris. That's what I type in to the command prompt to LaTeX every morning /begin stream. I have OBS running through LaTeX now. The Hochschild-Serre spectral sequence. That is the other one that gets name dropped here. So maybe that's what we want to look at. Maybe just let's look up that one. See what it's like. Where do we start? Wikipedia? Do we start with Wikipedia? Why not? Oh, good. This is a totally group cohomology one. Okay. Nice. The Lyndon sequence or Hochschild-Serre sequence relating the group cohomology of a normal subgroup and the quotient group to the cohomology of the total group. That is based. Friggin' based. Tech is Turing complete. I believe so. So that's actually not impossible. There should be a way. There should be a way to run OBS through Tech. So, how about that for a coding project? Sweet. Homological and cohomological ones. Very cool, and it holds if G is profinite. Or the Heisenberg group. Oh. Interesting. Okay, well that's what it is. But let's find a proof, yo. Could be in here. Oh, there's application. Maybe this other one here has a proof. Let's try and look at it all. Oh, hey, Russ. How's it going? Don't you just love it when you're trying to read through a pedagogical text and the author decides to use ambiguous notation? Like when? What's the example? Back to spectral sequences. That's right, Arad. We were actually back yesterday. We decided to head back yesterday. Who knows how long we'll be back for, but Um, we are back. We are back. Okay, let's check out how-to guide. Okay, so this is just going to be an application of this. The extension is not central, so we really have to be careful to think about the action of C2 on the homology groups later. Sending them emails. Hell yeah. Hell yeah. Well, I'm glad this is keeping you entertained. While you do the long writing task of emails. Fractal computer, you don't trust examples? Please take this as a matter of faith. Wait, you're saying the person in the textbook is saying that? How's that ambiguous notation? I'm confused. Okay, homology of the cyclic groups. Right, we got that. Sure. I buy it. More generally, this stuff. Okie doke. Okay, so we set up our E2 page. Wait, what page do we want actually? Right, this is our E2 page, yeah. Whoa, and I'm trying to... Okay, try to write down as many of the E2 terms as you can figure out. Okay, I guess we can use the statement, the statements above, right? I guess we can use the statements above to try and put this together for ourselves. No, you just can't think of a particular example. I see, but you've run into this a few times recently. I was just bugging you. No need to be sorry for being out of left field, not on this channel. That is not something one needs to apologize for. Okay, I don't know how we're gonna do this. Let's see. Okay, maybe I'll keep that there, and what I'll do is I'll make my own E2 page. Painstakingly handcrafted E2 page. So let's go E2PQ. It's going to be HP C2 HQ CN Z. Okay, so that's interesting. Yeah, I wonder, is split necessary? I guess maybe we'll find out in another case, but maybe if it's Wait, fractal computer, you don't like examples? I find this very hard to believe. I find anyone who's like, oh, I don't need examples, I don't like examples, I don't trust it. What's good, Leo? Primes that don't divide the conductor, am I right? Some people are non-constructivist. Fractal computers anti-constructivist. Yeah, that's good. All right, let me just make sure we're on the same P as the X coordinate convention. Yes, we are. Okay, time to make a big picture. Oh, you do need examples, you just don't like examples. Strange attitude, fractal computer, but then again, I'm a mathematician that live streams daily, so one could say that I am strange and that I should not have expected to attract anything other than strange behavior on my channel. 80 C2H. What will I make this one? 2 C2 Z. Boom. H0 C2 H2 C2 Z. Actually, you know what? Here's a better thing. Let's first, is it Z? Let's see what we're working with here. Yeah, these are all Z. So why don't we first just compute a bunch of the homologies. Okay, so yeah, let's write down a bunch of these first. You feel like that is inches away from just not liking math? Yes, indeed. But maybe that's also the case. Maybe Fractal Computer does math but doesn't like math. Okay, so what do we have? So basically, if this is even, H even C2 Z is basically, or no, it's going to be H odd. H odd will be Z mod 2, and then otherwise on the final, for 0, it will be Z. Okay, so that's a lot less writing for us to do. So then we can also just go ahead and try and just compute a bunch of the other examples, right? So HP C2 it would be 0 in almost every other case for, let me give myself more room here. The notation here could almost be an entropy calculation. I'm not familiar enough with entropy. Hello, Kostaka Kori. C2 of H odd. Oh, wait, but that's C. Wait, what are we doing here? What are we doing here? Right, sorry, it's Cn on the inside. It's Cn on the inside. So I guess maybe there's like a parity thing. Okay. Well, no, this should still be Z mod n in the odd case. Yes. So it's just going to be Z mod n in the odd case. You don't think one can personally fault someone for seeing generality and the fullness of abstraction as the primary beauty of mathematics? I guess, but what do you, like, it still doesn't make any sense. Like, what are you never going to consider a specific category or a specific set? Ever? It's just a weird, I don't know, like, I mean, really, why not just do like pure logic and never work with any mathematical statements at all? It's like the most general thing. I don't know. Well, you don't, but seeing that as a primary beauty of mathematics doesn't mean you disdain for examples. Yeah, that's also the other thing. Like, sure, you did say you do need examples, but to have disdain for examples, like, what counts as an example for you? Like, the category of categories is a specific category. Like, do you hate the category of categories? Do you hate thinking about that category? I don't know. Entropy often uses H. Really? That's weird. Okay. Sometimes with subscripts. Why would there be subscripts on entropy? HAB. So entropy is like the entropy of two states. What's the C mean? Given some other state or something? Growth and DQ universes don't exist. Yeah, you're trying. It's ban time. You're banned forever, Leo. Banned forever. Banned forever. Ah. Okay, I didn't do it, but watch yourself. Watch yourself saying that nonsense over here. Okay, so when this is odd, then this will be HP C2 ZN. Great. And oh man, life gets more complicated now. Have I heard of the induction principle of compactness? No. You're right, Arad. The category of categories is a two category. Should be thought of as a two category. You were told it's very deep and related to dependent type theory, but you don't get that big. Induction principle of compactness is a misunderstanding of two separate terms. That's what AI thinks. Topological compactness is an induction principle. Actually, Leo, I'm a higher category. I'm about to get so lit that I've got higher morphisms. I don't know what this induction. Yeah, Boris AI said you're whack, so it must be true. Damn, this is crazy though. Okay. Yeah, I don't really want to work this out, I'll be honest. It seemed like it was going to be nice, but now it's all these you say in general you'd say the primary purpose of examples is just pedagogical, but that's just totally false. I mean, like what about all of applied math, which is interested in particular examples? And you think one generally learns about objects and such better when seeing them interact with such things? I think it's important to not extrapolate your own learning style too much. Yeah. One generally learns about objects. Yeah, I mean that's a. I don't think I don't think I would agree with that. Not what the hell the blog post was correct. The blog post was correct. Yeah, exactly. Yeah, I was about to say, Leo. Yeah, when Gemini can literally bite Boris, it's gonna be a bad day. Can I privately fund math research? No, I don't have any money. Privately fund math research. Why? Why to my what? Why should you not generalize? Well, because then you'll end up saying wrong statements. Like what you said. I just don't think it's actually true that most people like most people need I mean, for the point of examples, right? Like, I mean, I do like very, there's lots of broad general structural theorems that I like, for example. But, like I said, I mean, a lot of, I mean, sure, we develop general machinery, but like a lot of these things are developed because like we want to be able to solve like particular examples. You meant someone can for a researcher? Yeah, I mean, I guess like all of applied math in the private sector. They're very beautiful and have great properties. What if aligned AI is AI that can only bite Boris? Ooh. Okay, let me go whip up that LLM real quick that bites Boris and Boris only. What about the machine learning model that bites all of the LLMs that can't bite themselves? Does it bite itself? You're not trying to be aggressive or argumentative or anything. Yeah, I didn't think you're trying to be aggressive or argumentative. But I mean, you're coming in here with wild takes, in my opinion. So I don't know. People are gonna have other opinions about your takes. Okay, I'm gonna read about this later though. This is Spectral Sequence live stream time. Let's do. Oh, the joke is that those functions don't exist. I see. Okay. Okay, maybe let's try and do some computations. What's interesting is actually the module. Oh, with trivial z coefficients. Okay, so the module action here was expressed, but actually, yeah. I guess we don't know what C2 action is happening on here, but maybe we can glean some information, right? So, and actually, what about the z case? No, even then. Okay. So let's try and write down some of this. It won't let me scroll lower until I make little marks here. Okay. So we will go H0, C2, Z, H1, C2, Z, and then there'll be a 0 here, and then an H3, C2Z, right? And then H1, C2Z, wait, or, what am I doing? Sorry, and then this one will be Z mod N. No, wait, the Y is the, oh no, okay, I'm crazy. Here's what it is. This will be H2. This will be H2, C2Z. And we know that this one's a Z, actually. And then we know that this is H0, C2ZN. No. This row is zeros. And then we have H0, C2, ZN, H1, C2, ZN. And H0 should just be ZN, right? And this will be H2, C2, ZN. And then we have another row of zeros, and so on and so forth. Either that or they're all constant. You forget the punchline. Something joke, holder continuous. Yeah, the punchline something. Obviously, constant functions don't exist. True. Urban legend about some dude who wrote a PhD thesis on it, and then during the defense, he couldn't think of any examples. I heard, of course, many people have a version of this thing, but I heard one that specifically the tale was from the University of Alberta, which is in the northern part of the province I'm currently in, from a couple years ago. And the story was that, yeah, they built this whole theory around these objects and didn't have any examples, and then it turns out that none of these exist. But, you know, I don't know how true that is. I feel like everyone has an urban legend about this. Does YouTube censor the word kill? Well, you wrote it there, so I guess not. Okay, I've got to get into a weirder sitting position. Well, I guess technically if you're Slavic, this is a normal sitting position, right? Which I'm like vaguely Eastern European origins originally. Heading off now? Okay, see ya. YouTube axed your last fire joke. Yeah, I would leave too if that happened. See ya, Leo. Since pure math is more theoretical, is the funding required is less than applied? Yeah, the funding to like do pure math research? Yeah. I mean, generally you don't need, yeah, two packs of ramen and alcohol. Yeah, that's basically it. That's basically it. We don't need no fancy laboratories. Okay, now I think I saw in this example, though, I think I saw that they had the differentials going the other way because it's homology. Yeah, okay, so I guess we got to think about that. I guess we got to think about that. So which way are the differentials going? Now it should be going. So let's see. dr should go from E R P Q, I guess, to E P minus R plus 1 Q plus R. Is that what's happening now? I'm guessing. So we can work out some stuff, right? So we know, I guess our E infinity page is supposed to be HP plus Q of the DNZ. Good morning, Mom. Good morning, Mom. Welcome to chat. Where are we here? Yeah, it should converge to the Z cohomology. With trivial action, maybe? Yeah. Okay. So, I mean, we know some things then, right? So, for example, I mean, as expected, this will survive to the E infinity page, and like obviously this is this. Not a surprise at all. I guess we could think about, maybe we could think about this Zn here. Yes, Jacko, you caught me live. Welcome to the live stream. And let's see, this here, Will anything ever hit it? This is the E2 page, right? So, yeah, is anything going to land in, what is this? This is E00. This is E01. This is E02. I know I should be able to just do it by looking at the pictures by now, but so, right, P plus 2. So, what is it? P plus 2, Q. No, P minus 2, Q plus 2 minus 1. So it's, yeah, over 2 and up 1. So let's see, 1, 2, right. So there's no differential here. And then let's see what happens on further pages. It would go, okay, on further pages there could be like a map over here, right? So I don't think we can rule anything out there yet, because it could get hit with stuff on the first row. Are simulations used in pure math research? I guess it depends on what you mean by simulations. But sure, I've done a bunch of coding. Yes, exactly, Jacko. This is the Hochschild-Lyndon-Serre sequence. But yeah, Goddard, I've used, I mean, my master's thesis basically had a bunch of code stapled in the end of it, even though it was all, yeah, very abstract theoretical stuff. Yeah, indeed, it's a good day to be Jacko, I suppose. A computer simulation. Yeah, but again, what do you mean? What do you mean by a computer simulation? Like what counts as a computer simulation? I mean, like, does just writing some code count as a simulation? Like, is using code to compute a bunch of examples a simulation? I don't know if you count that as a simulation. Like, I think about that a little bit differently than, like, you know, making some computer model of having, you know, two planets collide under gravitational forces or something like that, right? But in a sense, it's a kind of a simulation, if you think about it, like, you know, computing like what a bunch of large prime numbers do or something. So that's all I mean. I'm not sure what you're, I'm not sure if that counts as a simulation for you or not. Okay, well, what about let's look at H1 here. So we know there's nothing coming out of it, and there's nothing coming. It shouldn't hit anything either, right? Because already on the first page is going over 2 and up 1, so it's going to miss everything. So let's see if this is on E. This is E1 0. So then we know, for example, the E infinity page, what am I trying to say here? P plus Q. Right, so this will survive to the E infinity page. Wait, is E infinity... It's this, or should I be summing over? I should be summing over all the P and Q, right? Or... No, I guess it's just this. You saw the merch drop, community... Oh, yeah, I should have mentioned. I have hats now, guys. I have hats. I made a bonfire account. I also started a Patreon. I haven't... advertised it yet, but I'm going to start advertising that soon. I don't have, there's just a $1 tier where you don't get anything, and then there's a $5 tier. Then I'm going to have access to Discord, to a Discord server, because I don't know what else to do. But yeah, there's this post here. It's just a very simple, it's just a hat with QP on it. That's literally all. But I'm just seeing if people want to buy it. But let me know what other things you want. I don't know. Like, do you want me to put some commutative diagrams on some shirts or something? Let me know. You've seen large sets of numbers and complex geometry like higher dimensions type. It is way harder with paper. Okay. There are groups of people trying to understand, for example, what is the average rank of an elliptic curve? I mean, don't we already know? Haven't we proved that it's like 0? The average rank is 0, or rank 1 or something. It's like 99% is rank 1, and then like there's some rank 2 elliptic curves, and then basically all the others make up 0%. Isn't that proven already? Or is that still conjectured? You'd go for commutative diagram shirts? Yeah. Very particular about your boring plain black hats. Fair enough, Boris. Fair enough. Yeah, I got to think about what are my favorite kinds of commuting diagrams I could put on a shirt. Okay, so E10 infinity. So that's going to be, let's see. So H1 dn z is going to be E infinity 1, 0, which is going to be H. Wait, what am I doing? Or sorry, H. Wait, higher one. Wait, what am I doing? My notation's all messed up here. Do I have a grant for my research? No, I'm a PhD student, so I mean maybe my supervisor has grants, I guess, but I basically get paid to grade papers, and then I get paid to grade papers, and then in my free time I do research. That's basically how academia works. So this should be H1, because this survives to the infinity page. This should be H1 of this. But we can't, I don't think we can really answer this question totally until we actually know the C2 action on Z, since they also made a point about being careful about that. The conjectured average rank is 1/2. Oh. There's a theorem saying it's less than 1. Oh, interesting. Interesting. Well, what am I thinking? The density, okay, maybe the density and the average are different. How much do I need for research? As Boris already said, enough for 2 packs of ramen and some alcohol. That's basically it. I mean, I don't drink anymore because I'm going to live forever, so. Right, so most elliptic curves have rank 1. Widely believed conjecture, but not proven fact. Huh. Approximately half of all elliptic curves have rank 0, and the other half have rank 1. Right. I see. So it's conjectured, right? Okay, half of rank 1, half of rank 0, and then I think the rest are like 0%. Can I give a number estimate? No. I mean $0, or I don't know. The price of a laptop and like, I don't know, $50 worth of paper and pens for the year, maybe less. Like, yeah, Goddard, are you trying to fund me? If you're trying to fund me, Goddard, then it's $1 million a year. If you're asking because you want to fund me, the answer is $1 million a year. But you could probably haggle me down a little bit from that. Yeah, I just fumbled the peg. Yeah. Yeah. Well, I mean, also, like, yeah, what does it mean to fund research? Like, are you paying me enough to live? Are you paying me? Does that include rent? Yeah, I guess I need to factor in the cost of rent. So, I don't know. Like, what does the University of Calgary pay me? Like $24,000, $23,000 a year, maybe something like that. And I'm supposed to pay rent and feed myself on that measly budget. Okay, we did a little bit of computation. I need $1 million if you're paying me. If you're asking if you're asking because you want to pay me, the answer is I need $1 million. But yeah, the honest truth is no. I need $0. I need whatever. What's the University of Calgary paying me? Your family is in rental business, so you're fine. What does that mean? Does that mean you're fine to pay me $1 million to do math for you? Try to write down as many of the E2 terms as you can figure out. Wait, did they say what the action, though, is of C2 on here? Wait, because is this even true in general for coefficients in a CMA module? This cannot be a general statement, right? This is probably for the trivial action. There's no way this is independent of the CM action on your A module. Let's see what's going on then. Oh, I like that they made it blank so you could print out this page and do it yourself. Using explicit calculations in a resolution, one can show this. Okay, take this on faith for now, sure. Let's see what the footnote says. Oh, see, Viable. Okay, maybe we're going to head back to Viable. Maybe we'll head back to Viable sooner than later. 1 million equals H crore here in rupees. That's a lot of rupees. You think it works for any coefficients because cyclic groups always have a 2 periodic resolution? Oh. Really? But would it not... because certainly, for example, the answer is different in cohomology. Like I did some computations recently of just C2 acting on an abelian group. And definitely, like... I think in one case H2 is like the 2 torsion. In the other case, it's like A mod the things that are 2 times something. So in the cohomology case, there's definitely a difference. Okay, but then maybe this allows us to work out some of this. Does after doing your PhD will go into industry? I don't know. I've applied for postdocs, but yeah, I don't know. Part of me thinks it would be nice to just go make money in industry. But how? How to make the jump? If there's a difference in cohomology, then you must be misremembering. Yeah, I believe so. For example, you will realize, don't tell me what to do, that on the vertical Q axis, we have the co-invariants. And then check that these are given by this. On the P axis, we have Z Z2 and 0 topological interpretation. All terms away from the axes are 0? Whoa, why is that true? All terms away from the axes are 0? Is tenure harder even for a PhD, bro? What do you mean by that? Is tenure harder than what? Harder than getting a job in industry, you mean? Harder than getting a job in industry? Okay, let's try and compute this. So H1 C2 of Zn with, what's the action? Yes, I would say tenure is harder than getting a job in industry. Yo Yorichi. Okay, so we were told the action here, because this is E1 2. This is E1 2, and so I think we're told to take on faith what the action is. Okay, but actually we can maybe compute the group. I mean, if we ignore it and we just take this part on faith, this should be what? Oh, well, we might, hang on, no, we might need the action. So what is the action supposed to be? So C2 on H2I minus 1 on here is multiplication by minus 1 to the I. So here we want 2I minus 1 to be, is this 2 in this case? Right? Because this is H2 of CNZ. Is that right? H2 of CNZ? No, because I thought H2 is trivial. Now I'm confused. Now I'm confused. Oh, is that because I wrote things wrong? Is that because I wrote things wrong? Right, I put things in the wrong place. This is, the even rows should be 0. Guys, why didn't you tell me that I did this? The even row should be 0. This row is where it's non-zero. Okay, so really I want to be looking at E11. So I want to be computing E11, which is H1 C2 H1 CNZ, which is H1 C2 Z mod N, or now, so 1 is 2I minus 1. That implies I is equal to 1. So C2 is acting by inverses on Z mod N. Okay, great. And what can we say? So now let's go look here, have a little look-see, and we're going to compute, so H1 of CM, well, this is C2 on Zn should be, wait, that's what we're computing, right? H1 of this guy, yeah. So that should be Z mod N fixed points modulo the norm map of Zn. Well, let's see. What are what are our fixed points? I think, will that just be 0? No, there could be, that sort of depends on the parity of n, right? That sort of depends on the parity of n. Because, for example, in Z2, if this was Z2, its fixed points would be Z2. But if it were Z3, its fixed points would be 0. For Z4, the fixed points would be 0, 2. And if it were Z5, the fixed points would be 0. So, right, and then Z6, there should be 2 fixed points again, right? So yeah, depending on whether it's even or odd. So we're going to get, if n is even, it'll be a copy of Z mod 2. Maybe I should even write it explicitly. It'll be 0 and n over 2 mod the norm. If n is even, and it will be 0 otherwise. But now let's take a look at what the norm, the image of the norm is in Zn. Well, yeah, let's see, what's the norm map here? The norm map is just the sum of the generating elements, right? So, so that's just 0 plus 1 acting on an arbitrary element. So that's going to be m minus m. So the norm is 0. Wait a second, that can't be right, because I thought we were supposed to get that all of these things are 0. But that seems to not be the case. It seems like it can be non-zero in some places. Did I make a mistake? Gang, you're supposed to be catching my mistakes for me. Right. Did I make a mistake? Yeah, what are the affix points? I was right about the affix points. I'm sure I'm right about the norm. All terms away from the axis are 0. Now we argue that there are no non-trivial differentials, so the spectral sequence collapses at E2 page. Can I solve the extension problems? No. In the end, there was an oddness assumption, so I was right. Haha, haha, I am the king. Haha. I'm the greatest math genius that's ever lived. Nice. Okay. Okay. Is that maybe a stopping place for today? Let's see. There's this other PDF here. Do I know string theory, loop quantum gravity? Not in the slightest. I'm vaguely aware of what they're about, but that really ain't my thing. You know, I have about as much of an understanding as any other, you know, casual layman would. Maybe slightly more, because I know like what math words mean. Yeah. Let's see what's going on in this PDF. Okay, this is more topological. It says class field theory PDF. Interesting. Classification theorem. Maybe we'll take a closer look at this tomorrow. Oh yeah, so there's BG, and we're going to do things in terms of BG, I guess. Maybe loop quantum could lead to new foundation of math? No, that doesn't make any sense at all. A new foundation of math? How? Why? That doesn't make any sense. Why would quantum mechanics lead to a new foundation of math? Like, I guess it's not totally inconceivable that No, it still doesn't make sense. Like, it still doesn't make any sense. Like, all of the math in loop quantum gravity can still be formalized in whatever. I mean, this is the whole point of having a foundation of math in the first place. You make a system robust enough that everything could be formalized in that system. So I don't see how or why that would be the case. Yeah, it's a lot of functional analysis in Hilbert space. String theory did lead to new advancements in math. Absolutely, that's true. But that's very different than new foundations of math. Oh, a rod coming in with a possible counterexample here. A fun little thing called the Bohr topos with internal logic. That's fair. Although, so I guess it could be the case that, yeah, you decide the right math with which to do loop quantum gravity. You end up taking different axioms that are outside of ZFC or orthogonal to ZFC or something. But like, yeah, is this Bohr topos really a new foundation of mathematics? Topos theory is like these sort of foundations were discovered a long time ago. But I guess maybe it's not so crazy to think that one could, come up with some specific type system for purposes inspired by loop quantum gravity. But then the odds that people are going to, accept mathematics like that, yeah, definitely not a new foundation. Like, there's people, logicians are making up new foundations all the time. When I went to this summer school in proof assistance, like, they were telling me that, yeah, there's like millions of foundations out there people are like making up all the time. Does pure math have a mathematical conception of time? No, but yes. I don't know how to answer that. Where's the difference between pure math and physics in terms of geometry or numbers? In the math of general relativity, time is put on an equal footing as space. So is that happening in math? A lot of time, when we talk about homotopies, right, we think of them as some like path that depends on a parameter time. That's how we think about it, but then I don't know. Yeah, I'm not sure how to answer this question. Wow, this document looks cool. Something seems weird about the typesetting though. Like, that is weird. But there's something else. I can't put my finger on what it is. Like this. There's something very strange about the way that this is typeset. God, yeah, and this res? Come on. This is a great document. I think we will come back to this tomorrow and we'll learn a lot from it. But that being said, Sergio, you gotta up the tech here. Now build an infinity bore topos and come up with quantum homotopy type theory. Yeah. Okay, I think that's a stream. That's a stream for day. Tomorrow we come back with more Lyndon-Hochschild-Serre spectral sequence nonsense, baby. I'll see you then. There are things called temporal logics, and whose topos internal logic is related. Yes, I've heard about such things. Something about where you have topoi that depend on some time variable. But yeah. But oh, Mom, you're still here. Have you been here the whole time, listening to me yap about my nonsense? Well, I'm glad you've been entertained. And yeah, that is all. And